Good afternoon, all. Good afternoon.
Hi, how are you?
How are you, Sonia?
Good afternoon.
How is Nairobi today?
Thank you. How are you?
Great.
It's warmer than usual, so that's a good change. How is Harare?
Let's test a bit for audio. Am I clear on your side, Faith, and you, Sonia? Am I clear?
Internet is a bit
Yes, I can
bad,
hear you.
so I don't know.
Okay. There is some background. Faith, can we hear your audio? Let's hear.
Okay, good afternoon.
Hello, Faith. How are you?
I'm doing well.
You are clear. Faith is clear. And Sonia, can we test? Can we test?
Definitely. Yes, just tell me if you can hear me and see me clearly.
I can't hear anyone at the moment, but I can see that Sonia's lips are moving.
Oh, so you can't hear
Oh, that's
Faith. All right. Faith, can you hear me? Faith?
I think we may have lost her.
Yes.
At least she's still on the line.
I'll also post the password on the group just to help those that are struggling. I think that's the right.
I think that would definitely help.
That's the right password. 6EQ3QS. Okay, that's fine. I was expecting 2 more people. That's Lindy Webkize. She works for SAS SAS South Africa, and also a business partner to Faith. Faith, is a business partner going to make it?
Can anyone hear me?
Oh, I think Faith can.
I can hear you, Faith.
It's my network, I'm not sure.
But I can hear you. I can.
Yes, we can hear you.
Okay, that's fine. Maybe I hand over to you, Sonia, or we wait a little bit.
We can wait a few more seconds if we can see if we can get 2 or 3 more people to join.
That's okay.
Otherwise, you can tell us a bit about yourself in the meantime and about African Master Seed.
Okay, thank you.
Have you enabled screen sharing?
Okay, let me do that. Right. Do I click on the green?
No, that will share your screen. Instead, what you do is look for the settings and then maybe enable screen sharing for everyone who's attending.
All right. Okay, so do participants, one participant can share at a time, multiple participants can share simultaneously? Is that okay? I'm going on multiple participants can share
Yes,
simultaneously?
maybe this is okay.
Okay, that should do here?
Yes, that will be fine.
Okay.
Yes. All right. Well, if we're not going to have any more people joining us, I think I can just get started.
Okay.
And then the journalists, they will catch us
That's
along
fine.
the way as we go. Is
Thank
that okay?
you. Thank you.
All right, fantastic, fantastic. So first off, I'm very glad for you, Stanley, for setting up this meetup for IPFS. And maybe I can just give you a brief introduction about myself so that Faith can also be caught up on what I do and maybe how I came into the IPFS system. So again, my name is Sonia John, and I am a developer. I'm also a writer and a speaker, and I write and I speak and I write code about decentralized systems and distributed systems, specifically IPFS. And you can always reach out to me on GitHub, on email, on Twitter, or on Telegram if you have any questions about blockchain or about distributed systems or about what we're going to talk about today, which is IPFS. And the reason I wanted to set up IPFS today, to have this IPFS meetup today is so that I can introduce as many people in Harare to what IPFS is, to provide developers and pretty much anyone who's interested in opportunities around the decentralized web and the technologies that build it, like IPFS and IPLD and more. And the reason that I am passionate about IPFS community meetups and IPFS communities around Africa is because I think the decentralized web unlocks a very important value, which is the ability to easily transfer value without the use of centralized institutions that act as clearing agents or act as pretty much what we would call the central authority on what gets shared on the internet itself. So one of the things that is essentially built into this is the fact that the internet as we know it today has become one of humanity's most important technology. We use it to buy things on the internet. We use it to communicate to friends and family, to people in different places in the whole world. We use it to watch videos. We use it for communication. We use it to publish articles. We use it to read research, to publish pretty much anything. We use the internet for a lot of things. And one of the reasons that IPFS came along is because the web as we know it today has a lot of challenges, and some of these challenges include, come from the fact that it's a very centralized system that essentially gives a lot of power to just a small group of people who can then decide, for example, whether a user can access the internet or certain platforms or certain providers, right? CEOs of very large companies have turned a lot of the companies that they currently own or the companies that they've already built into gatekeepers of information. And through decentralization as well, we've come across a lot of challenges around data policies where users are required to agree to the collection of their personal data, which is then monetized by selling them to third parties, for instance. Um, the centralized systems around the web today also expose a lot of users to security and privacy incidences like data breaches. At this point, we probably hear about a data hack maybe every once or two weeks, you know. Sometimes it can even be two hacks announced every week. And these architectures are also vulnerable to denial of service and distributed denial of service attacks. In essence, how the web is structured today and the centralized servers that essentially power the web today are single points of failures, in the sense that when they fail, the websites and the application that depend on them also fail. So then how does IPFS come into this? Well, IPFS, which stands for the Interplanetary File System, is a synthesis of multiple peer-to-peer networks which work to make the web work peer-to-peer, in the sense that you don't have to rely on a central server to get access to any information. You can use, within the IPFS network itself, connections are done from peer to peer, which means that if you're connected to the IPFS network and you're requesting information, you could just request it from another peer as opposed to a centralized server, or what we'd like to call the local net or the local network environment. So in this illustration, for example, the top here, the domain name, example.com is the location of an image that we would call buzz.png. And how this works is if you're requesting, for example, on Google, the image buzz.png, what the Google search engine will do is that it will look for the host server for this image. And if it's at example.com, it will then return this address and the location will be the header of the image that you're looking for. Whereas on IPFS, if you upload an image on IPFS, if you upload any content or any object specifically to IPFS, then the content itself becomes the address of the object that you've added to the IPFS network. And what it does is the next time you're looking for this image, as opposed to giving you the location of the image, it will send back the address of the image itself. So this is what we call content addressability on the net, which is very different from location addressing, which is how the current internet structure actually works. But then how could we use such a system in our day-to-day lives? Well, IPFS has multiple use cases. And some of these use cases, as I have highlighted in the slide, are built on different values, like values of freedom of speech, freedom of assembly, giving users control of their own data. For example, decentralized control of information, and readers and writers are guaranteed privacy when they're using the IPFS network. And what then happens is this kind of infrastructure, this kind of network becomes very dependable because it's not based off of a central server, in the sense that there's no server that can go down and you would suddenly lack access to the IPFS network itself. And it also gives users a lot of self-sovereignty, in the sense that you can control what you want to share with the public. You can control how you want to store your information. You can control who has access to it, as opposed to what we have currently on the web, which is your data is being collected, sometimes without even your knowledge, and then shared with multiple third parties, again, most times without your knowledge. So the five major use cases, or the five use cases that I could break down a lot of IPFS into, is secure self-publishing, secure communication, secure storage, verifiable transactions, and trustless infrastructure. I would like to go further and try to break down some of these examples, but if there's any questions so far, I can take them.
Let's welcome Lindiwe from Johannesburg, South Africa, and Kadiki in Harare. Welcome. Sonia Jones is on the platform. We shall allow her to proceed, or you can ask her questions. Thank you.
Thanks, Stanley. Thanks, Sonia.
No problem. You're welcome. All right, well, if there's no questions right now, I can try to give examples of how we could use IPFS on a day-to-day basis, for example. If you're using the IPFS network as a secure publishing platform, some of the things that you could use IPFS for is for academic application. For example, if you wanted to publish academic papers, you could do that on IPFS. Because one of the other major features of IPFS is that if an object is stored on the network, then the object that has been stored can, one, it's immutable, which means it cannot be changed, and two, it cannot be deleted. So it's a permanent web in the case that if you added an object, it will be on the IPFS network forever. So if, for example, if you wrote a thesis on a very critical subject and you wanted this information to be available to the public forever, you could add this paper to the IPFS network, and it will remain available forever in that instance. We could also use it for public and community data. Say you work with a community group or you're working with a public group, and you had information that was relevant to this group itself, and you wanted to share it with them, again, in a very permanent and public way. IPFS is ideal for that. Also, if you wanted to store a huge volume of data off of the IPFS chain, you can also do this because IPFS has unending data storage capacity, because most of the people who run IPFS nodes tend to run them on their own machines, on their own phones. So if you were, for example, running an IPFS node and you were pinning information on the network, you could then also pivot into Filecoin, which is where you get paid to store information for other people. And IPFS is also great if you're working with a lot of information management systems. You can build a lot of management systems that are based on IPFS or built on top of IPFS. And these are just some of the aspects of secure self-publishing that are involved with IPFS. You can also use it to build trustless infrastructure, right? If you didn't want to build infrastructure that needed an authority to manage them, then IPFS is great for that. So if you wanted to build web browsers or decentralized web browsers, if you wanted to build applications that are based on distributed big data or machine learning, or if you're managing a lot of intellectual property databases, IPFS is ideal for this. And I can give you an example here. In Rwanda, the government is trying to build a land registry. And the way that they're doing that using blockchain, the properties of blockchain is all this information about land and registries and who owns them and how big the land is, etc. All of this information is stored in a distributed database that can be accessed to everyone and is immutable, which means it's not changeable. It cannot be changed. You can also use IPFS to run supply chain management services or applications, right? And also, if you're working with a lot of large data, say, for example, medical data or academic research, if you're part of a large institution that has to deal with a lot of data, for example, IPFS is ideal for archiving a lot of data sets. It's also ideal for storing and distributing packages or containers or smart contracts or even games, right? If you're interested in data management dashboards, these are all applications, different applications of IPFS. Any questions? Before we go into the different implementations of IPFS? Or no, I can take questions at the very end. So let me just go through the rest of the presentation. Or alternatively, you can also leave your questions in the chat, and then I can get to them as we go along as well. So currently there are two major implementations of IPFS. I don't know how many of you are developers or you have developer experience. But Go IPFS and JS IPFS are the two major implementations of this network. There's currently work going on to build it on Rust, and I think Python as well. I can be sure. But what these two implementations of IPFS do is they have a lot of similarities and differences, but they're built this way because then it gives a lot of users multiple options if and when they want to get started using IPFS. This slide is pretty technical. It covers a lot of the different sub-protocols that are already built into IPFS as well. But some of the technologies that they both share, which are the core technologies within IPFS itself, is that for transports, both Go IPFS and JS IPFS are built on TCP and WebSocket technology. We also use a lot of distributed hash tables. What these distributed hash tables do is they're able to track data within the IPFS network in the sense that when you add an object to IPFS and it's chunked and it is stored on different nodes, what the distributed hash table will do is that it will track every piece of data so that it can know where it's stored, on which node it's stored, and if at any point you wanted to retrieve this information, what the DHTs will do is that they'll retrieve this information and give it back to you. And then there's a lot of other features, for example, garbage collection, Quick, which is used for security. There's also relays and tunneling and a lot of private networks. For example, if you're not interested in building a network that was accessible to the public, you can also build your own private network within IPFS. For this, we use a technology that's called an IPFS cluster. And I like to think of it as an alternative to AWS, because if you were an organization and you wanted to use all the components of distributed technology within your own organization, but you do not want to share this information with the public, then you could set up your own private network or your own IPFS cluster that has, say, 10 or more nodes that are only available within this private cluster that can be used by the organization to share information within itself, right? So that this is usable if you are working with sensitive information, if you're working with information that is not yet to be made public just yet, but then you also still get to enjoy all the different benefits of decentralization. If you wanted to get started with Go IPFS, there are a lot of guides that are already available that can be used to install like Go IPFS. The easiest place to go is at the Go IPFS download link. I'll share all these links with Stanley so that he can share them on the group in case anyone wants to get started. There's also the option to use the core API, the embedded client API, or the HTTP client API. These will mostly come in handy when you're getting started developing your applications on IPFS. And again, like we mentioned, very different kinds of applications can be built in IPFS. And it also works, and the reason we have multiple options for getting started with IPFS is because all of these are ideal for all different kinds of applications, right? So if you were building a browser-based application, then you would use an HTTP client API. if you were building a mobile application, for example, then you could use the embedded client API. And if you just wanted to run your own node, then you could just download Go IPFS, set up the node on your computer, and you can get started storing your information or your data on the network. There's also JS IPFS, which is, again, the second implementation of IPFS. It also has all the multiple ways to get started using it. We use a lot of JS IPFS for browser-based applications because JS, which is JavaScript, is a versatile language that's already optimized for a lot of browser-based applications. So if you wanted to build, say, a social network, a distributed social network on IPFS, this would be the best place to start. You could use either the core API, you could use the IPFS companion, which is already available on multiple browsers like Brave or Chrome, and also on Opera for Android. If that's the browser that you use, then you can also use IPFS there. And then there's also the JS HTTP client. And this is my favorite because it's the one that's widely used currently for browser-based applications. This year alone, we are recording at least 13 million requests a day. So these are requests of data that are being made to and from the IPFS network. And in the last 6 months, there's been about 2 billion data requests. And that's pretty amazing. The JS HTTP client runs a service worker, and the service worker essentially connects your HTTP gateway to the IPFS node that you're running, and that's how you can send and receive data from the IPFS network. There's also other ways of getting started, like I mentioned earlier. If you use browsers, then if you use, for example, Brave, MetaMask, or Opera Mini, Opera for Android, then you can easily use IPFS on any of these browsers. But if you have a website already that you like to send customers to for a business that you're running, or for an institution, or for a community that you've built, and you have a website, or you're planning to build a website, these pinning services make it very easy for you to get started deploying your website to IPFS. Fleet, for example, can deploy a complete website to the IPFS network in under 10 minutes. The ENS, or the Ethereum name server, and unstoppable domains, these are great tools that we currently use to provide a decentralized domain to a website. And what I mean by a decentralized domain is, as opposed to domains that we use today on the internet, the .com, the .org, the .net, which are run on centralized servers, what ENS and unstoppable domains do is that they're built on decentralized systems. Unstoppable domains, for example, is built on top of IPFS, and ENS is built on the Ethereum network. And what they do is that they create service space for a user within each of these networks, so that when you create a domain using either of the solutions, then your domain cannot be taken down, your domain cannot be deleted.